Okay, so now we are group 7, lesson 6 and 7.
Awesome.
Okay.
Did anybody
did
have
anyone-
a question? Sorry.
I don't know what I'm doing. I feel like I'm just kind of going along and just regurgitating the numbers, but
I like that word.
I definitely feel that way. Like, it's like on the second lesson of every week, I'm always like, what am I doing?
Yeah, why is that the second lesson seems a lot more rigorous lately than the first one?
Yeah.
I hate that. When I'm doing it, I'm okay, but when I'm doing the homework, it's like, where did that question come from? Did I really? So I have to go back and reread it, and it's taking me forever to do the samples. So, but it seems like when I do it like 3 times, I get it right.
yeah. Yeah. Well, did anyone have any questions on any particular thing, or are we ready to start the quiz?
I'm ready to start the quiz. Lesson
let's
6,
quiz.
right?
Yeah, lesson 6 quiz. All right, let's do this, people. Let's get 100.
12 questions. Here we go.
Answer false on the first one. Oh, wait, that's
No. But I'd be happy to read number 1 to begin with. I'm just kidding. Okay, I'll jump into 5. Let's see here. When calculating, do not round until your calculation is complete. All right. Did I say 5? I meant 3. When you are taking a sample size of N5, what is the shape of the distribution of means histogram when the parent population is right skewed? I'm going to say skewed right.
Yeah, I was
Agree.
thinking the same thing.
I'm going to agree with you on that one.
I'll take number 4. When you are taking a sample size of n equals 100, what is the shape of the distribution of means histogram when the parent population is right skewed?
Normal.
Yeah, I was going to say normal.
Right, because it's kind of a big sample size, right?
Yeah,
Yeah, because they said
bigger than 30.
yeah, bigger than 30, yeah.
Gotcha. Okay. Who's got
Who
5?
wants 5?
I guess I'll take 5. When you are taking a sample size of n equals 5, what is the shape of the distribution of means histogram when the parent population is normally distributed?
That would be normal.
Say normal.
Yep.
Normal.
Agreed?
Yes.
Sounds good to me.
I'll do 6.
Who wants? Go for
I'll do
it.
Okay. When you are taking a sample size n equals 100, what is the shape of the distribution of means histogram when the parent population is normally distributed? Normal.
Normal.
Agreed.
Agreed. And why is that again? Big sample size, and it's already normal to begin with, right?
Exactly.
Yeah.
Is it my turn
Oh,
again?
look, we're going to answer that. I think Minerva's up.
Even me. So, wait. When would the distribution of mean be normal distributed? Choose the correct response. Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample is large. Data are drawn from a population that is right skewed and the sample is small. I'll be the second one.
Yep.
Well, it's more than one.
I think it's
It
all
is?
but the third.
Yeah,
Yeah.
A, B, and D.
Yeah, it says choose all correct answers. Or
Oh.
responses.
You
Anybody
normally-
can say right with that answer there.
You can prove
Yeah.
that with the example for the first couple of questions.
Yeah, because when it's
Oh,
when
that
it's normally distributed, when the population is normally distributed, the distribution of means is always,
normal.
it doesn't matter what the sample size is.
Right. When the parent population is normal.
Yeah.
That makes sense.
But if the parent population isn't normal, but the sample size is large, then it will be normal.
Yeah,
Correct.
exactly. So A, B, and D, right?
Yes.
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 Yes. Question
Yes.
8. Which of the Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean X will follow a normal distribution. For bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean, about 95% of the data will be within 2, and approximately 99.7% of the data will be within 3. If the sample size is large, the sample mean X would be close to the population mean U. I think that's what that is.
Yes.
If the sample size is large, the shape of the distribution of sample means will be approximately normal. So which of the following gives the best explanation of the central limit theorem? I think it's, would it be D?
That's what I went with.
If the sample size is large, the shape of the distribution of sample means will be approximately normal.
Yeah.
What do you guys think?
That's what I chose.
I'm having a hard time with that one, though.
Wait, what did you choose?
I put D.
B, like as in Bob?
D
He's
like
a dog.
Dog. Okay, I was like, wait a minute. Bob doesn't make sense.
Well, Bob is something else. I can't remember what that's called. The law of, what is it?
That's the 68, 95, 99.7
Yeah.
rule or something. Yeah, that's why I was like, wait. Yeah. So in my notes, it says central limit theorem is when the sample size increases, all possible means become approximately normal.
Yep, that would be
Yeah.
D.
Which is
Okay,
what D
now I
says.
agree.
Okay.
That was some hard evidence. I don't think we can dispute that.
Yes.
Okay. Use the following information to answer the next 4 questions. Let X be a random variable with population mean U equals 10 and population standard deviation, whatever that is, equals 6. Suppose sample size of N equals 36 is drawn from this population. What is the mean of distribution of sample means? I need to refer to my notes, but I want to say 10. I need to pull up the textbook.
I think, yeah, I'm going to say 10 because isn't it the, it's basically the same.
The population mean.
Yeah.
Yes, then.
That's what I am thinking.
That was easy.
Wait until you have to do the formula.
Yeah.
Yeah, I'm checking my notes.
Right?
Do a formula on that?
So what is the standard deviation of the distribution of sample means? Standard deviation.
Okay, so it's gonna be
6?
well, isn't it gonna be the 6 divided by the square root of
36. Yeah.
Oh, right. Okay.
1, right?
Mm-hmm. 6 over
1.
6.
Yeah.
Regardless of the distribution of the population, if the sample size is large and is greater than 30, what would the shape of the distribution of the sample mean? Normal?
Yeah. We're whipping through this.
The other one,
All right, what theorem would justify your response to the last question?
Central limit.
Central limit theorem.
Are you guys cutting out? I keep hearing cutting out. Sorry.
wait, I'm behind. So when you did the formula, the answer was 0.1, right?
We said 1
1, no points.
because the square root of 36 is 6, and then it was 6 divided by 6.
Oh, okay.
And then for 11, we said that the distribution would be normal,
Normal. Yeah.
and that's because of the central limit theorem, which is misleading. You'd think it would be the law of large numbers.
That
Right.
sounds awesome.
That's where they get you.
Yeah.
Yeah.
Are we ready to submit?
Yeah, I was gonna say I'll go ahead and submit. Be the sacrifice.
I got 100.
100.
Yeah, me too.
Sweet.
Knock that out in 10 minutes, guys.
That was 12
Hold up.
questions of beautifulness.
I doubt that's going to happen with lesson 7.
Yeah, that just means it's lesson 7 is going to be hard.
Yeah, it's exactly what that means.
Equations on 7. 7. I'll take 1 and 2.
Wait.
Got jokes.
I'll go and start with 3.
No, wait.
Ready?
I'm looking for it. No, I'm not ready.
Okay.
Just wait.
I am
Oh
so
my
ready.
God. You guys go like 1,000 miles per hour.
All right, so question number 14. I'm just
Oh
kidding.
gosh.
No, wait.
All right, whenever you're ready, you let me know.
Yeah, just wait. I'm getting there.
All right, guys, I'm going to take a nap.
Yes.
I'm just kidding.
Enough in the meantime.
Minerva, did you get 100 on that last one?
I did, but I'm just
You
fixing
didn't?
my computer. I'm fixing my computer because my screen is all completely blocked with my test, so I don't
Oh.
So hold on. Okay. I'm just changing screens. Hold on.
Okay.
Oh. Sorry. Oh my gosh, this is so funny. No, it's not funny at all. I don't know what I'm doing. Okay, now I know what I'm doing. No, I'm not. So- oh my gosh, guys.
You want
I
to do a
lost
screen
my
share?
text.
Can I help guide you?
Hold on. Okay, so this one goes over here. Then it goes over here. Oh, I am so sorry. I lost my paper.
Your assignment?
Yeah, hold on.
Not only are the second lesson quizzes harder, they're also longer.
Like 3 questions, right?
Yeah.
Oh, that's a lot of math.
Yeah.
Oh,
Yeah.
Yeah, it's no multiple, like, there's hardly any multiple choice.
Was this the class that we have open note tests?
I think it was one page of notes.
1 page of notes?
Yeah.
I can type pretty small.
Yeah.
size 4.
Exactly.
No margins.
I don't know how to make my screen smaller, but
Do you want to share your screen? We can see. We can try and help you.
yes. Can you see it?
Not
just-
yet. Did you click the little green box that says screen share?
Yes.
Oh, you did. I don't see anything.
I just see that stupid character. I can't remember what his name is.
So sorry.
No. What is his name?
It is what's his name? It's Buck Wild from Okay, hold on. It's Buck Wild from Ice Age, the Dawn of the Dinosaur. So I have to change it. Next week I'll have a brand new picture of me.
I was like, wow, Minerva, you look different.
Right? Okay, I found it.
Yay.
You got it?
Yes, I got it.
You ready for question 3?
No, it's loading.
Huh.
Oh my gosh. Okay, I'm ready for question
I'm
3.
not going over the first 2 questions again. All right, question 3. Are we ready?
Yeah.
Yeah.
Minerva? Okay. Use the normal probability applet to find the combined area under the standard normal curve that is right of 1.358 and left of negative 1.358, and round to 3 decimal places. I got 0.175.
Yeah.
Yep.
Same.
Number 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations X, the distribution of the sample means, or this cannot be determined from the information given. Okay.
I cannot determine it, so I go with C.
I can't either. Well,
I'll go with C too.
let's see. If 9 observations are randomly drawn from a population, I guess we'd have to know how big the population is, right?
Yeah.
Yes.
And so it has to be C.
Let's see.
Okay, I can do 3. Which of the following results implies that the spread in X decreases as the sample size increases? I don't know. I've got to
It
look
wouldn't
at
be
this.
central limit this time, would it? That
Central
really has
limit.
nothing to do with it.
I'm not sure. Let me look in the textbook.
So I think it's the law of large numbers, and I may be totally off.
Well, I did a quick search for the law, the word law in chapter 7, and it never came up. So
So yeah, you're right. It's the law of large numbers.
Here's what my notes say. It says law of large numbers talks about accuracy. As sample sizes increase, sample mean will draw closer to the population mean. So does
and
that mean
that's from lesson 7 or 6?
that's actually from lesson 6?
Let me go back and reread that one.
You know what? Here's my other notes, my actual written notes. It says law of large numbers. If the sample size is large, then the sample mean will typically be close to the population mean U. And then it happens because the standard deviation will get smaller.
Well, okay. I mean, I don't have anything to refute it.
I don't know.
What are we saying then?
We're going with law of large numbers, right?
Yeah, I think so.
All right. We are very confident.
Law of large numbers states that the sample size gets larger and the sample mean gets closer to the population mean, meaning it gets
Yes, that's exactly it then.
close together. So
Okay, I'll do number 6. So using all the following information above, Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? And round. So we have to do that.
Formula.
Yeah. Which,
So the mean is 150.8. And the standard deviation is 8.8.
Okay. I'm kind of lost here, I'll be honest.
So we have the mean, we have our score, and we have the standard deviation.
Okay.
I got 1.045.
Yeah, that's what I got too.
Okay, so what did you guys do?
So you take Diane's score, which is 160, and you're going to subtract the mean from it, which is 150.8, and then divide all of that by the standard deviation, which is 8.8. It's that formula that we had from even last week, I think, too.
And then round it. Don't forget the rounding.
Round it,
okay. Yeah. See, I was making it more complicated.
So what did you get?
1.45.
1.045. So it'd be 1.05. No, 1.045. Yeah.
Yeah, that's fine.
Yeah.
Okay.
All right, number 7. What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE?
Okay, so do we need to plug that into the? So do we take the Z-score on the applet? Yeah. And then do everything to the right of it is my guess. And then that area, 0.148.
0.148 is what I got.
Yeah, that's what I got.
Hang on. Yep.
Yep.
Wait, I'm not. Oh, shoot. What did you got? 0.48?
0.148.
Oh, okay.
Do you see how low?
I'm having a hard time when I have to highlight the blue lines.
Oh, like it clicking in there?
Kind of like when you enter the Z-score.
Yeah.
I'm always get confused which line you have to highlight. You know, the blue line, the blue colors.
Oh, you're confused as to which area you're supposed to highlight?
No, like when you enter the number on the Z-score on the applet, you have to, at least on mine, you have to highlight the blue, like if you want it above or less.
Yeah.
I always get confused which one it is, though.
Well, on this one, they wanted it above 160, so you would go to the right of the far right line, the positive Z-score.
Yes.
Because this is above the mean, right? Because the mean was 150.8.
Uh-huh.
So 150.8 would be in the middle.
Yes.
So you want to go to the right of 160, right, to go above 160. So all that area above 160 is higher than Diane's score.
Okay, got it.
That makes sense?
Mm-hmm. Ooh, okay. Next one is, are we ready for 8?
Yep.
Yeah, go ahead.
A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the Z-score corresponding to the sample mean of the students' scores? Run your answer to 3 decimal places.
First thing we need to do is find the mean, right?
Right.
Yeah.
Yes.
Find the average.
So 800 divided by 5. Mean is 160.
160. So it's going to be the same z-score as above. It's Diane's.
Yes.
So 1.045.
You guys agree with that?
Correct.
Yeah, I agree with that. Yeah.
So I'm sorry. So what did we do?
I had to think about it.
We found the mean, and the mean
You added all the numbers.
Oh, yeah.
has Diane.
You added all the numbers, and then you divided it, and it gives you 160. And it's the same score as the answer number 7.
Oh, yeah. Yes, it is.
Okay.
Wait, it's the same as the answer to number 7 or number 6?
Answer to number 6.
Okay, that's what I was thinking.
Yeah, sorry. Number 6, yes.
That's okay. All right. Okay, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? Round your answers to 4 decimal places.
The same as number 7?
Yeah, I'm thinking that's the sample scores that we want to use, right?
Yeah, that's what I was thinking, but we have to round it to 4.
That is greater. So 0.1480.
0.1480.
Yeah.
What?
1 to 34.
Oh yeah, I see.
0.1480.
Yeah. Okay, is everybody good on 9?
Yes.
Yes.
Okay, so number 10 says, using the information above, what is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? And it's going to be, I say approximately normal.
Yeah, because it's a pretty big sample size.
Yeah.
Correct.
That's correct.
That's in the homework, I believe. So she did your homework is there.
Are we ready for 11?
Ready.
What is the mean of the distribution of the sample means for all possible samples of size 81 that can be drawn from the parent population? What is the mean of what is that asking? I'm confused by that question.
The mean of the sample means?
Yeah, it's going to be the same as the mean, which is 3.5, right?
Wait, where'd you get 3.5? Oh, there it is.
At the top, yeah. At the
mean of the sample mean. Yeah, I guess it would be 3.5.
Yeah.
All these questions are a lot easier than the way they make them sound.
Seriously?
No.
Wait.
No, it says what is the mean of the distribution of the sample means?
Right.
So we have to do actually. We have to do.
Oh, it's the central limit theorem again.
We have to do a formula for that one.
Let me look at my notes here. Formula. Mean of the.
So you have to do the deviation, the formula of the deviation by means equals the, what is it called? The it's the mean over the sample. Am I right?
I'm lost for this question.
I'm lost too.
Okay, so if you have in your homework, on on lesson 6,
Okay.
there is an example that is the same. You said, what was the standard deviation of the distribution of sample means? So there is a formula that we need to find out about the deviation of the means, which is the,
But this one, but in question 11, it's not asking for the any type of like the Z-score or anything, which is where you have to, isn't that where you have to use the formula?
No, you don't use the Z-score. You just use the mean, which you use the number of samples. Like it will be the 3.5.
So I found this section in the textbook. It says the collection of all possible sample means X is also a population. The mean of the distribution of sample means is the population mean.
Uh-huh.
Oh, so that's 3.5 then, right?
No.
Yes, I think it is.
Yeah, because it says suppose the mean GPA of BYU Idaho students is 3.5.
Yeah, so this one doesn't need the formula at all. It's just, this one is basically just stating what Kendra said, that when the population mean, then the sample mean is going to be the same.
Okay.
Right. Yeah. I think the formula you're thinking of is to find the standard of deviation.
Yeah,
Of all the means.
which we'll probably do in the next question.
The
Fine,
next
yeah, the
question,
standard
right?
deviation for the sample mean.
Yeah. Yeah.
Gosh.
Yeah.
Okay. Sorry, guys.
No,
Okay.
you're good.
We're all learning.
We were all confused. So.
All possible samples. So then this one's going to be the 3.5 divided by the square root of 81.
Right. Yeah.
Yeah, that's what I got.
Okay.
Wait.
So 9.
0.389.
Yeah, that's what I got.
0.38 repeating with the 9 at the end, so yeah.
Okay, so what did you guys say? See, we're all learning. Now I'm lost.
So the formula to find the standard deviation is
Okay, is the little circle, the thing with
Yeah.
the square root of it.
that
Yes.
thing. Exactly.
That
Right.
all
Okay.
makes.
So then it'd be 0.7 divided by the square root of 81, right?
Oh, is it 0.7? I did 3.5. I'm sorry. Let me double check here.
Yeah, because the mean is 3.5 and then the standard deviation.
I cannot keep my little symbol straight here. So the standard deviation symbol is that circle one with the little tail.
Yeah.
Oh, yes, he's right.
Yes.
He's right. Yeah.
Okay. Wow, I'm so glad no one listened to me. So it's 0.7 divided by 9.
Yeah. Yeah. You're right.
Yeah.
Okay.
0.0777777.
Yeah.
Okay, so how many places do we have to do? So-
Three.
Three decimal
Point.
points. So 0.078.
Yeah.
Oh, geez. Okay. What is the probability that the mean GPA? Is everyone good on that one?
Yes, I am now.
I am.
Okay.
what is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? Round your answers to 3 decimal places.
We can use the applet for this one, can't we?
Well, do we need to find the z-score?
Uh-huh.
So do we do 3.3 minus 3.5?
Yes.
Yes. And then we divide that one.
We divide that by the deviation.
Yeah, by
The
3.
0.7.
Mm-hmm.
7
7 by 81.
divided by the square root of 81, right?
Uh-huh.
Whoa. What?
0.411 repeating, right?
Wait, why are you doing this the square
Wait.
root?
Wait. I don't know. I'm just going. I have no idea what I'm doing.
Because I think we're just trying to find the
We're
z.
just doing the z-score formula.
So wouldn't we do 3.3 minus 3.5 and then divided by 0.07?
No.
No, we have to have the square root in there. We're finding the z-score, right?
Yeah.
Yes.
Yeah, so it's the value minus the mean divided by the standard deviation, but the standard deviation for these is the standard deviation divided by the square root of n.
Why?
I don't know, it's in my notes.
It's in the textbook, I think. I'm trying to pull it up.
Yeah, let me see if I can.
I love how stressed out we get about the second group quiz.
I know, the
Every
first one we're like, we rock.
Okay. Well, I found it in the textbook. So once we have determined that the sample mean is normally distributed, we compute the probabilities with x. We first compute, and we do that formula with the square root. Then use the normal probability applet to compute probabilities about z. Okay. So 3.3 minus 3.5 is negative 0.2. And then we do the square root of 0.7?
No, you do 0.7. Oh, hold on. You do 0.7 divided by the square root of 81. So 0.7 divided by 9.
Okay.
And then divide that by 0.2. So negative 2.
I'm completely lost.
In
Yeah,
the,
0.9.
I got 0.9950.
That would mean that the probability is 99.5%.
no, we
Yes.
plug in, I think that's the z-score, isn't it? Are we?
Z-score.
No, because your z-score is minus 2.574. So if you put that one on the applet, it gives you the probability of 0.9950.
It's a pretty high probability.
I've got to catch up here. Okay. Standard.
The probability that 81 students will have a GPA less than 3.3.
Well, if you think the answer should be less than 50% because the mean is 3.5.
Right.
I have
Okay, so
Higher than 50 or 0.5.
I have 0.389. I don't know where I got that from.
Wait, what is it? Is it that they will have less than? I have 0.0052.
That's so small.
Okay, so that doesn't sound right. Okay, so we have to do 3.3 minus 3.5, which is negative 0.2. Oh, that's what I did. I did it
Yes.
wrong. Okay, so you have negative 0.2 divided by 0.078.
0.77 or 78.
And then I have negative 2.56.
Yes,
So then I plug that into my the app.
Mm-hmm.
the app.
And then I'm just using the little blue area. Would it be?
But which
0.06.
area are you highlighting?
I'm hiding the area to the left because it said that would be
minus.
less than.
Okay.
It gives us a really high probability, though, doesn't it?
No, it's 0.0051.
52.
Yeah, I told you I'm having a hard time on highlighting the blue ones. So
So
I got also the same 0.0051.
Yeah, and we just have to round to 3, so I think it's just 0.005.
Yes.
Yep.
That's a really low probability. That doesn't sound right.
That's the mean
Doesn't sound right.
for 81. Well, I don't know. I mean, it's a lot of. I mean, to take 81 randomly selected students, maybe it really would be a low probability.
Oh, this is the probability that the mean will be less than 3.3.
Yes.
Okay, so it shouldn't be less than 3.3 since the bigger sample mean was 3.5. And so that probability is probably correct.
Correct.
I think.
Oh, okay.
We did I did the formula right. I'm not only having a hard time on highlighting the blue. That's why it went like 99 something. So 99 minus 100 is 0.005, right?
Yeah.
Well, 99
Sorry,
100 is
That's
1.
1.
But I
That's why
think
I said
it's 0.005.
Well, it's actually negative 1.
Yes.
Yes, you were right. It'd be greater than 3. Okay, well then we select everything else. 0.995, right?
Yeah.
0.995, yeah. Isn't that the
It's just the not the opposite, but how do you say it? Subtract the probability of question 13.
Because they have to equal 1.
Right. Just
Right.
do 1 minus question 13's answer.
Yeah.
This is the opposite. There we go.
wait, okay, so it would be 0.995.
9.5.
Yeah. Oh my gosh, why does 15 have to be so long?
Who volunteers to distribute?
Okay, so we're on number.
15.
Oh wait, okay, I'm sorry. I was still on 13, people.
Oh,
Oh,
well, so 13 is 0.005.
Yeah.
14 is 0.995.
Yeah. 0.995. Okay.
All right, everybody with us.
Yes.
Okay.
I'll read 15. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after Americans got really fat. Sorry.
Oh my gosh.
I'm sorry. I'm just kidding. Okay. But was raised after a tragic boat accident. That's terrible. Okay. Sorry. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answers to 3 decimal places. Note, as extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but also values that are far away from the mean as ours in the positive direction. Okay, well that's great.
So we're going to do the left and the right.
Right. I'm correct, yes.
Okay.
So 185. So we're going to do we do
So you do
177.6 minus 185 divided by 26.7?
no, isn't it 185 minus?
Oh.
It doesn't matter for the first part, does it?
I guess it doesn't. No, 'cause I don't know. I'm confused.
That was creepy, whatever that sound was.
The telephone?
Is that what that was?
Yeah, I think so. Okay, so 185 minus 177.6 divided by 26.7. And that's our Z-score, right? I got 0.277.
0.27.
So then we want the area of both the left and the right. So I
Wait.
got, okay,
0.78.
that's what I got, 71.
Oh,
72, I mean,
0.782.
yeah. Do I, let me try doing the reverse.
Just the middle.
I want to do 177.6 minus 185. Yeah, it would just be the negative of that.
So did you do the standard deviation where it's the standard deviation divided by the square root of the number?
No.
What?
We just find the scores for both of them.
Well, so the weights of a random sample of 48 commercial boats were recorded. So then do we have to do 48 divided by the square root of 26.7?
It must be 9.28.
Or it's
No, it
it's
should be the
26,
square root of 48.
yeah, 26.7 divided by the square root.
The way around.
Gosh. This is crazy. Okay.
That's 0.385 or 3.853.
So that's the standard of deviation for the sample, right? That answer?
Hold on. Just
So I got a z-score of 1.92. Did any?
Nine close to having an answer.
Okay.
So you did one.
I did 185 minus 177.6.
Mm-hmm. Did you divide? So I did. Is it gonna 3.8353? Like divided by that? So
Yeah.
7.4
Yeah,
divided.
7 divided by 3.8538. I just did. And then I got 1.92.
Okay, that's what I got.
Okay. And then we just want
The
The
left.
left and the right.
the left and the right, right? Correct?
So 0.055.
0.055, yeah.
Yeah. Everybody with us.
I'm still working on it. Hold on.
Okay.
So it's kind of confusing to me because to find the z-score, there's two different z-scores because then there's two different formulas.
Correct.
But it looks like we're working because this one is to find the mean when you have the mean, right? I don't know. I have no idea what I'm talking about.
I think it has something to do with like when you have a specific sample number, maybe. But I could not say for sure.
Okay, I'll have to look it up.
And so we have 0.055 then, right?
Yeah.
That's
Does,
what
does most everybody agree?
Yes.
I'm going to submit and I'll let you guys know.
all right.
Oh, are we done?
I think so.
I sure hope so.
Okay. So, oh my gosh, you guys, we did horrible.
Really?
Yes. We got a 76.
Not horrible. That's just mediocre.
Average. No, see. All right. Which ones do we need to rework?
Number 4.
Number 4. So apparently it can be determined.
Oh,
Which of the following will have smaller standard deviation if 9 observations are randomly drawn from a population? Sample means.
I think it's A then because it's a bigger population, right?
I was going to say B for no reason at all.
Oh,
I was joking. Which of the following would have a smaller standard deviation if 9 observations are randomly drawn from
Oh,
a
it's smaller one. B.
Well, is 9 considered to be large? Well, no, because it's smaller than 30. I don't know.
Oh,
Distribution of sample means.
Individual observations.
That's what you think?
I think so.
Can you defend your answer?
Yes, the individual observations are 9. The population is a lot bigger. And so
Wait,
the
wait, wait.
standard
What
deviation-
question are you at?
4. Which of the following would have? Okay, so
So the standard deviation is a lot more important when there's a smaller sample size. Right?
individual observations. Oh my gosh, I don't even know.
I think our brains are just done.
yeah, we're all fried. I'm gonna look at the notes.
Yeah, I'm looking in the textbook. Question about possible sample.
Do you think it will be the distribution of the individual observations?
I do.
Mike does think that, yes.
I'm going to put that one.
Okay.
Thank you for your vote of confidence.
Well, I'm sorry I can't get behind you. Sure, why not?
Are we just at that point?
Yeah.
Okay, so question 4 was wrong, and then question 8.
Oh.
8 was wrong?
8
How did
was
we
wrong.
get that wrong? That was one of the easy ones.
8 and 9 are wrong.
Oh, jeez.
Great.
8, 9, and 14.
But we got 15 right.
15 is correct.
Woo. 8, 9, and how can 14 be wrong?
I was just going to say, how is 14 wrong, but 13 is right?
Yeah, that makes
Oh,
no
you
sense.
know what? I rounded 4 places.
Oh,
What did you guys get? I put 0.0095, so it should be
oh, no,
It should be
0.995.
0.995, yeah.
okay. So that's what I got wrong.
So 4 and what else?
4, 8, and 9.
Okay, so we really just worry about 8 and 9 then, right?
8, I have
Yeah.
1.045. That's what,
Yeah, so do I.
and then 9 is 0.1480.
Hmm.
Okay.
All right, so let's find the mean again.
Well, it's 160.
Okay, I'm going back to do my second quiz now.
Oh, yeah, go for it.
$800 divided by 5, 160.
So do we need to do the whole
Wait, what question are we working on?
Number 8.
Number 8. Okay.
I bet we have to do the
Yeah, we have to do that fancy pants formula.
with the square root, but we would do the sample size of 5. Do we have the standard deviation? There's the standard deviation. Okay. So what is, oh gosh, I cannot remember what these symbols mean.
What it looks like.
So what I'm going to do is 160 minus 150.8, 9.2, and then take the square root of square root of 5, which is 2.236, and then do 8.8 divided by 2.236 for an answer of 3.935. So then 9.2 divided by 3.935 2.337. Well, I have no idea if that's right.
2.337.
Yes.
What did you get? 0.3?
2.337.
Yeah, 2.337. Actually, it's going to be 2.338.
So you have, what is it? So it's, and then the standard deviation is 8.8, right?
Yeah.
Divided by the square root of 5.
Right? Because that's a sample size.
Yeah. Which I have is 3.935.
Yeah,
So
that's what I
do
did.
9.2 divided by 3.935. And I
Yeah.
got 2.33.
8.
Yeah, 2.338.
That's what I got.
2.338. Okay, that's what I have too.
So then we put that into the applet.
No, because that would already, it's just asking what the z-score
No,
is.
she's asking for the C-score only.
Right. But I'm saying, well, for 9, sorry, that's,
Oh, yeah, for 9, then we put that in the 2.338. Yeah. 2.338. And we just go with the,
The right side.
yeah.
yeah,
And I have
0.009.
7.
7. So 0.01 would be,
Well, no, it just says round your answers to 4 decimal places.
oh, it said 4. Okay.
Yeah.
Okay.
It's 0.0097.
0.097.
Okay, I'll submit mine.
So what you got on that one, sorry? Sorry.
0.0097.
Yeah.
You're going to the 4, right? 4 decimal place. Okay.
Yeah. Yeah. Did you get that, Minerva, with the blue to the right?
And yeah, that's why I'm
Hey
asking.
guys,
on
don't
that
submit
one.
it yet.
I'm learning
Question
how
4.
Well, I already
Highlight
submitted,
it.
and I was going to tell you, Mike, that you were wrong.
I was wrong. Oh my
Uh,
gosh.
But that's
4 is still wrong?
Which one's
4
the
is wrong. The answer is B.
4 is B.
Okay.
It was a
But
good
everything-
effort though.
Is
I
everything
couldn't hold
else
it back. I'm
correct?
sorry. I should have been more humble.
Is everything else correct?
Yeah.
Yes.
Okay, because
What else we had?
I
For-
actually wrote them down. I wrote them down.
Well, that's
Well,
amazing.
4?
While
Tell
you
me.
guys were arguing about number 4, I wrote everything down.
Oh my goodness.
Can you tell us what else we had?
So wait, what was the answer of the 14?
0.995.
0.99. Okay, yeah, I got that one.
Yeah.
Tell me.
0.995.
Oh, do you need the answers?
Yes, please.
Okay.
What's
Oh, hang on. Sorry.
You ready?
Okay, it's loading. Okay, go ahead.
So number 3 is 1.75.
No, it's 0.175.
0.175?
Yeah,
0.175.
Yeah, 0.175.
4 is B? I know that.
Yeah, 4
4
is
is
B.
B.
Hey, Mike, 4 is B.
Thanks.
Okay. 5, law of large numbers, right?
Yeah.
Yes.
6.
1.045.
Okay.
Correct.
0.148.
Sorry, say again.
0.148.
Yeah.
Okay. And number 8.
2.338.
Number 9.
0.0097.
Ten is approximately normal.
Yep.
Okay. 11.
3.5.
Oh yeah. 12.
0.078.
13.005, 14.995.
Yes.
What was 15?
0.055. Okay, so
Ooh.
you guys, I'm going to just stop recording.
Yeah, go for it.
Okay.